breaking something down and putting it back together. This is a process that helps people understand how things were made. A person will be able to redo and reproduce an origami by unfolding it first. Knowing how cars work requires understanding each major and minor mechanical parts and their purposes. The complex nature of human anatomy requires people to understand each and every part of the body. But how? By dissecting it. Reverse engineering is a way for us to understand how things were designed, why is it in its state, when it triggers, how it works, and what its purpose is. In effect, the information is used to redesign and improve for better performance and cost. It can even help fix defects. Imagine if the Trojan horse was truly inspected and torn down before it was allowed to enter the gates of the city. This will probably cause a few dead soldiers outside the gate fighting for the city. The next time city is sent another Trojan horse, archers will know where to point their arrows, and not dead soldiers this time. The same is true for malware analysis. By knowing the behaviors of a certain malware through the reverse engineering, the analyst can recommend various safeguards for the network. Think of it as the Trojan horse being the malware and the analyst being the soldier who is initially inspecting the horse, and the city being the network of computers. Anyone seeking to become a reverse engineer or an analyst should have the trait of being resourceful. Searching the internet is a part of reverse engineering. An analyst will not plainly rely on the tools and the information we provide in this Udemy course. There are instances that an analyst will even require reverse engineer to develop their own tools. Software auditing might require reverse engineering. Besides high-level code review processes, some software quality verification also involves implementing reverse engineering. The aim of these test activities is to ensure that the vulnerabilities are found and fixed. There are a lot of factors that are not taken into consideration during the design and development of a piece of software. Most of these are random input and external factors that might cause leaks, leading to vulnerabilities. These vulnerabilities may be used for malicious intents that not only disrupt the software, but may cause damage and compromise the system environment it is installed in. System monitoring and fuzzing tools are commonly used when testing software. Today's operating systems have better safeguards to protect from crashing. Operating systems usually report any discrepancies found, such as memory or file corruption. Additional information such as crash dumps are also provided in this course. For this information, a reverse engineer would be able to pinpoint where exactly in the software they have to inspect. In the software security industry, one of the core skills required is reverse engineering. Every attack, usually in the form of a malware, is reversed and analyzed. The first thing that is usually needed is to clean the network and systems from being compromised. An analyst determines how the malware installed itself and became persistent. Then they develop steps for uninstalling the malware. In the anti-malware phase, the steps are used to develop the cleanup routine. Once the anti-malware product is able to detect that the system has been compromised, the analysis provides information about how the malware was able to compromise the system. With this information, network administrators are able to impose policies to mitigate the attack. If the malware was able to enter the system because of user opening an email attachment that contains JavaScript code, the network administrator will implement the blocking of emails that contain JavaScript attachment. Some administrators are even advised to restructure their network infrastructure. Once a system gets compromised, the attackers may already have got all of the information about the network and will easily be able to make another wave of the same attack. Making major changes will greatly help prevent the same attack from happening again. Part of restructuring the infrastructure is education. The best way to prevent a system from being compromised is by educating its users about securing information, including their privacy. Knowing about social engineering and having experience of previous attacks make users aware of security. It's important to know how attackers are able to compromise an institution and what damage they can cause. As a result, security policies are imposed, backups are set up, and continuous learning is implemented. Going further, target companies can report the attack to authorities. Even a small piece of information can give authorities hints to help them hunt down the suspects and shut down malware communication servers. Systems can be compromised by taking advantage of software vulnerabilities. After the attacker gets knowledge about the target, the attacker can craft code that exploits known software vulnerabilities. Besides making changes in the infrastructure and software used should also keep up to date with security features and updates and patches. Reverse engineering is also needed to find vulnerable code. This helps pinpoint the vulnerable code by backtracking it to the source. All of these activities are done based on the output of reverse engineering. The information gathered from reverse engineering affects how the infrastructure needs to be structured.